two.
Take two. All right. 1, 2, 3.
Happy birthday to you.
Deja vu.
Happy birthday to you. Happy birthday, dear Laura. Happy birthday to you.
There we go. All right. Okay. Let's recall what we looked at 2 days ago. So here's what we had. We were doing number 2. Here's the situation. We had a semicircle, and we were asked the question, with a semicircle of radius 2, what is the area of the largest rectangle that we can place inside that semicircle? This is the classic type of thing that an engineer would be asked to do. It's a type of situation. Here's a problem, okay? We need to be able to make some space in here. You know, in any kind of situation, they'd say, all right, we need the dimensions of the largest rectangle that we can place in this space that we have. Go find it out. Like, okay, then what do we do? Okay, well, we identify what we know. We said this, all right, let's plant this thing on a coordinate plane. The semicircle has coordinates 2, 0 here, negative 2, 0 there. We know that the area of a rectangle is length times width. We know that we don't know what the dimensions are, so we use a variable. We say, let's plant x there, and a y is the y coordinate there, even though we don't know what they are. We said that the equation for the circle is x squared plus y squared equals 4. And then if we solve that for y, that means that the y coordinate is actually whatever the square root of 4 minus the x squared coordinate is. Okay, that's our relationship between the two. Then we said this. We identify what we want, and we said that we wanted to maximize the area of the rectangle. That was the goal. That's critical to identify what we want to know, what we want to be able to do. Because then it leads us into what the equation is. We said that, all right, we've got this equation. We'll use a of x. So the area is dependent upon x. And we said we know that it's length times width. But more specifically, come over here, what was our length? What is this guy right there? It's actually 2x. That's the length there. And what is the width? The width? It was y. Okay, so we said, all right. So we multiplied 2x times y. But 2 variables is bad. Okay? So we want to be able to only work with 1 variable because we're doing calculus of a single variable. So what did we say we do? Yeah, we play coach. We say, oh yeah, that's right. The y coordinate is dependent upon the x coordinate in this manner. So I can replace y, or do a substitution for y, and replace it with 4 minus x squared. And this is my equation that we're going to maximize. This was a quick review of what we did 2 days ago. And now what we're going to do is we have to maximize this equation. How do we do that? You're scaring me. Find the derivative and set it to 0. This was all the curve sketching stuff. Look at your list of things that we were supposed to do for every single problem. Now we're going to apply our curve sketching techniques in order to figure out where the maximum occurs. So, A prime. And what am I going to use to take the derivative of this? Product rule. So you got to stick with me on this. We got derivative of the first, which is 2, times the second, plus 2x times, what's the derivative of 4 minus x the square root of 4 minus x squared. You should be able to do this in your head. Say it again.
2x, just kidding, I lied. 1 over 2 times.
Yeah, don't even give me the final answer. Where would it, what would you do first? Let me just give it to me as you would say it.
So the 1/2 power, so you multiply it by that.
So you bring the 1/2 down. Then it's 4 minus x squared to the what power? Negative 1/2.
So the square root.
What's that?
It's still the square root.
It's still the square root, but now it's going to be in the bottom.
Okay, so you still need square root.
I can write this, like I could write this as, what we're doing is we're finding the derivative of this. So that is the same as 4 minus x squared to the 1/2. And then if we take the derivative of this, it's going to be 1/2, 4 minus x squared to the negative 1/2, multiplied by negative 2x. This is the whole chain rule, the mama and the baby, finding the derivative, just like we had that. So we're almost done here, now we multiply this by negative 2x. All it is a derivative. You have to make sure that you're seeing the connection between, we did all this work with finding the derivative. And we did all this work with finding maximums and minimums, and where it's increasing and decreasing. Now we're combining all that stuff together. Okay, at any given time, we should be able to pull out any one of those things. All right, well, let's clean this up. This is the derivative. This is 2 square roots of 4 minus x squared. What do we got here? I see 2's cancel. Okay, who's upstairs? Negative 2x squared. And who's in the basement? Square root of 4 minus x squared. That whole piece of algebra there turns into this. Yes?
Where did the 2 times the square root of 4 minus x squared come from?
Product rule. Everybody gets to be the derivative in
Uh-huh.
the first one. That one was the
Oh,
derivative.
times the word, okay, sorry.
Okay. So now we got this thing, a prime of x. We found the derivative. Okay, what next? Right. We're going to set it equal to 0. We're going to find critical numbers. So we're going to say 0 equals 2 square roots of 4 minus x squared minus 2x squared over the square root of 4 minus x squared. And we got to solve. Okay. How do we solve that?
Multiply square root of 4 minus x squared over.
Exactly. We're going to clear fractions. The best way to do this is to wipe out the fractions. That is, multiply everything by the common denominator, which is the square root of 4 minus x squared. The reason why that's cool is because it gets rid of the fraction and it makes the whole thing a lot simpler. So we multiply these two, what do we get? 0. Okay. Now we apply the Santa Claus property. That's just because we're at Christmas there. Okay, so Santa Claus distributes, right? Gifts. Okay, so when we multiply square root of 4 minus x squared by 2 times the square root of 4 minus x squared, what do we get? 2 times 4 minus x squared. Okay, because the square root times the square root gives you the item that you were taking the square root of. And then, when we have Santa Claus distribute here, we get minus 2x.